Welcome back to a lecture series on igneous and metamorphic petrology. And this topic today, it is in discussion and continuation of the earlier discussion what we have made, understanding of the magma, how magma is setting, is getting settled or is getting started crystallizing, understanding from unique component system, understanding from if the magma composed of a single composition, what will happen. If the magma composed of two compositions, what will happen? Two n series composition, what will happen? Two different series composition. So from different angle, of course, a binary you take a number of binary can be model. And this discussion, it is in continuation of the earlier discussion of single component magma crystallization understanding and double component magma crystallization. And this is a magma composed of three different composition. In that case, what will happen to a magma when it starts crystallizing itself or solidifying itself? So this discussion on ternary system, and there are two examples we are now going to explain about the three different composition. These two model, it is not only with the two model it is existing, it is a number of combinations you can think and then you can bring. And what we have seen, the classification based on silica content, based on the silica absence. And similarly here also we can do a lot of combinations and understand. Of course, many petrologists, senior petrologists, they did a lot of exercise, lab exercise on this to understand how a mineral formed from ternary system. And this is one examples of ternary system. The diagram represents with three component of three constituent ternary system, ternary eutectics. There are two words normally used. What do you mean by ternary eutectic? You have three component. You take any two component. What will happen to these two component? Whenever these two join together to form, that is called eutectic, as we have already discussed. What is the meaning of eutectic? Here, ternary system also play a major role on understanding ternary eutectics. It means on three you have 1, 2, 3. You have three composition. Either these two will form together, or these two will form together, or these two will. There are three combinations on which two different compositions will start to crystallize parallelly. So it is also called ternary eutectic. Sometimes three will join together at certain temperature. So understanding of this is called as ternary system. Three constituent is involved, crystallize simultaneously at a constant temperature. At a particular point, three will start together to form, crystallize. It is not a solid solution series. It means it is not albite anorthite. Similar, exchanging of sodium to calcium. No, it's not like that. It is ternary eutectic at which this is called M. I will explain by the time you will understand what is ternary eutectic. And they have taken three examples of the composition of diopside, one end, forsterite another end, and anorthite another end. See, anorthite, forsterite, and actually they have to take here, over here, anorthite here, the diopside here 100%, forsterite here. So blue line is a forsterite phase, and this orange line is anorthite phase, and your pink line is diopside phase. Understand, assume like this. And there are three phases because it is a ternary system. This is one phase, and the other side is other phase. And so assume that it is a chamber. So in this chamber, magma is there. In the magma, it is composed. If the magma starts crystallizing, so the temperature is represented on the vertical column. So at this point, anorthite will start to form. At this point, forsterite will start to form. At this point, diopside will start to form. And what is this figure signifies that this is a line. This is a line at which you know that forsterite and diopside will form together at this point. So this is called binary eutectic point, and this is called a binary eutectic point of anorthite and forsterite. and this is a binary eutectic point of anorthite and diapside. That's what I ternary eutectic. It means from this composition, and from this composition. At this point, that you see it is a dip. From this phase it goes, from this phase it goes, from this phase it goes at a particular point, 1234 degree temperature. Three minerals will form together. So that is called ternary eutectic. This is binary eutectic of diopside phosphite, binary eutectic of phosphite anorthite. This is a ternary binary eutectic of anorthite. So assume that when the temperature reduces in the magma, as and when it touches this line, anorthite will start to form of different composition. Anorthite percentage is more and the diopside percentage is less, phosphite percentage is less. Slowly anorthite will form as and when it touches this point. What will happen? Diopside will form. When a magma at this temperature of the composition of diopside, as and when it touches this line, diopside will start to form. When it comes here and joins here, diopside and anorthite will start to form. Similarly, the same situation will exist at diopside phosphate over here, anorthite phosphate over here. And this is the junction at which three will form together. That is the speciality of this three component system. This is called ternary eutectic at M. So this is the explanation of the earlier figure. Crystallization of magma component: phosphite 50% diopside, 25% albite, 25% anorthite. That is the eutectic point. Eutectic point at which you will get 50% diopside, 25% albite, and 25% what is that? This one, anorthite. So this is the combination at which ternary eutectic will form. Phosphate composition will stand halfway down, the perpendicular from the diopside corner. So that's what you have seen, perpendicular from the diopside corner. This is halfway. It is 50% of phosphate in composition. The point at which three will join together and form. This is very very important point. That 1275 degree we have to keep it in our mind. At which you have your ternary eutectic will start to form. So diopside, phosphite, and anorthite will start to form. And phosphite is moved down and reaches the boundary of plagioclase field at G at a temperature 1235. This is the point. This is the explanation of the figure. So this represents the explanation of the figure. And they also have explained with another figure called diopside, anorthite, albite, by taking three component. This is a triangular diagram is the representation. This is 100% diopside, this is 100% of anorthite, this is 100% of albite. So at this point 1392 degree diopside will form. So albite will form at 1185, and this is at point at which you know that diopside and albite will form together. This is binary eutectic, 1085 degree temperature, degree centigrade. At 1274 degree temperature, you have your diopside anorthite eutectic. Both will form to here. So this is the point at which binary eutectic will occur. And 1553, it is the temperature at which anorthite will start to form. And as we know that albite to anorthite, it is that the variation of potassium, sodium to calcium, that the percentage is given here. The temperature is represented here. Temperature is represented. Temperature is higher. Temperature is higher. As and when it touches this line, three will join and form. So this is a line at which it is represented as a temperature of forming three ternary eutectic. So at this temperature, diopside and anorthite of higher concentration will form. Albite is very less. Here albite concentration will be more, comparatively diopside and anorthite will be less. At this point both three, no, this is at this point, as and when magma touches from here to here or here to here, as and when this is a very very important line. That is called, they have put ternary cotectic. It means three will form together, three compositions will form together, plagioclase composition. So at this point it will form together everything. That's why they have given plagioclase composition with 50%. Diopside crystallize at 1382%. Albite crystallize 1118 degree centigrade, 1553 degree centigrade. Triangle is divided by curve line in two fields, which is crossed by temperature contours, diopside, and plagioclase is the second from magma in the lower field. References we have taken from Tyrrell book and Hung book. So with this the discussion of ternary has come to an end. Thank you very much.